Yeah.
Yep.
Learning outcome 2 of software engineering. Yeah. And
Okay.
the learning outcome 3 would be obviously discussed in the next class on Wednesday, hopefully. So in the learning outcome 1, software engineering, we discuss certain principles, discuss the process, and obviously models of the software, engineering. Then, discuss the uh, difference between the traditional and non-traditional, methodologies. Like, let me show you a little overview. Like, it started with the principles of the software engineering, then, we came to software development methods. We gave a kind of classification from waterfall model, V-shape, prototype modeling to one kind of traditional one, and the agile one was considered as, the uh, an approach which has definitely the conventional steps, but the sequence is not sure. They take the directions of those sequences of the system development cycle on their own. So do you recall this about the agile one?
Yeah. Yeah. I recall all this. Yeah.
So agile one, is uh, if we have a look on this, a kind of hierarchical tree, then certain methodologies, fall under this, under these categories, like a process oriented, are these blended one, are these object oriented, are these like OOA and RUP, rapid one, are they these, and like this is a kind of classification. But also remember that so far none of the classification has been, has become standard. Yeah.
Yeah.
Maybe after some time they can, come under the same different tree. Yeah. And under different leaves, so that's not sure, but just, they have defined. Yeah.
Yep.
So these, after, waterfall models and prototyping models, all these, methods, we discuss, I think we completed the whole slides.
Yeah. I think we did. Yeah.
Yeah, okay, that's fine. So,
Yeah.
the recall is that overall, the software development needs to be carried out, the by the steps like and requirement analysis, design, implementation, and testing. However, the each methodology, yeah, or model will have their own arrangement of, sequence.
Okay. Yeah.
Okay. Now we come to the LO2. LO2 is the key aspects of the software engineering that we will be discussing today. What are the key aspects? Like a requirement analysis is, important. Design or system design is task design. Design task or system design. That's also, the key aspect. Implementation task, software development and business information, organizational aspects, programming teams, software engineering roles, software engineering tasks. So these are the key aspects we have to discuss today. So how they look like? Normally, uh, after understanding the software engineering, and their methods in the, LO1, LO2 is mainly the discussion about, uh, software engineering practices, multidisciplinary nature of software development, explain the structure of software engineering teams. So the, you know, uh, this LO itself, yeah, doesn't have any sequence of the topics, to be honest. Yeah. So
Okay.
let us, cover again these, words given in the LO2, and again I would show you a connected path for studying these topics, in a sequence. Yeah.
Okay, yeah.
So requirement analysis task. So we are talking about the key task of the software engineering. Requirement analysis is the first stage in the system engineering process and software development process. It encompasses those tasks that go into determining the needs or conditions to meet for a new or altered product, taking account of the possibly conflicting requirements of the various stakeholders such as beneficiaries or users. Requirement analysis is critical to the success of development projects. Requirements must be actionable, measurable, testable, related to identified business needs or opportunities, and defined to a level of detail sufficient for system design. Requirements can be functional or non-functional. So according to this slide, so everything is based on the requirement. I mean, the successfulness, yeah, of the project is basically dependent on the requirements. Yeah.
Okay, yeah. Yeah.
It says there are the two types of the requirements. One is the functional and the other is the non-functional. So can you recall what is difference between the functional and the non-functional requirement?
Yeah, the non-functional was the requirements, wasn't it? And then the functional is actually what it does.
Can you restructure your answer again?
The non-functional was it like the requirements of the system, and then, or is it the other way around?
Not near to the correct. Can you say again?
So then the non-functional, basically it describes what the system should do.
Yeah.
And the non-functional, the functional is what it actually does.
Yeah. And basically, okay, let me tell you. The functional requirements are that what functionalities technically needs to be provided, A to Z.
Okay.
Yeah. And the non-functional requirements are how those functionalities, work.
Okay.
Well, I mean, how those functionalities work well.
Okay. Yeah.
So you can, drive the, context of non-functional requirements from the functional requirements. So you provided the functionality and how well the functionality performs.
Okay.
Yeah. So
Yeah.
the performance word would be more appropriate for the non-functional requirements.
Right. Okay.
Yeah. How
Yeah.
those functionalities perform is basically the non-functional. So performance would be measured from, let's say, availability. Yeah. For example, you are saying that it's a database, then you would, or for example, if you are saying that it's a website, then the non-functional requirement would be the uptime, the availability time shouldn't be less than 99.5.
Okay.
Yeah, that's
Yeah.
availability. Yeah. Latency. Yeah, how delay is the latency, how jitter is in the transmission. Yeah. So
Yeah.
these are basic, how availability, the quality. Yeah. So these are basically the non-functional requirements. So even they are measurable. Yeah, but it is basically the performance.
Yeah. Okay.
Yeah, so non-functional requirement is termed as a performance, requirement.
Right,
And
okay. Performance. Yeah.
you cannot implement the performance, but you can only judge the performance.
Right. Yeah. Okay. Yeah.
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 But it is basically the requirement which is, which has a kind of weight. Yeah, weightage.
Yeah. Okay. Yeah.
So the requirement analysis, you should be analyzing the functional requirements as well as non-functional requirements. Yeah.
Yeah. Okay.
So next, the requirement analysis issue. One of them is stakeholder issues. Users don't understand what they want, or users don't have a clear idea of their requirements. Yeah,
Yeah.
is that clear? Because even they don't know, yeah, that normally what happens, they know, yeah, that what they need, but they can't explain that how they need it.
Yeah. Okay.
Like, if somebody can't speak, if they are saying something, but they can't say express.
Yeah. Okay. Yeah.
That's the main thing. Like, it takes too much time to understand what they really mean.
Mm.
Would you read these, 2, 3, lines? Let's see how you, you know, participate. Sorry. Yeah. The next line. Hello.
Hello. Yeah.
Yeah. Can you read, for me this one?
Yeah. Users will not commit to a set of written requirements.
Yeah.
Communication with users is slow.
No. Basically, commit is to be committed. Yeah. Whatsoever they, provide the written requirements, but they always, try to, uh, you know, try to be, try to change their minds.
Yeah.
Users will not commit to a set of written requirements, no matter you give them, any kind of best, written document, but still, they won't be happy.
Yeah.
Users insist on the new requirements after the cost and schedule have been fixed. That's a big problem.
Yeah.
Yeah. We have
Yeah.
the requirements because of the commitment. Even, they committed. Yeah. Commit is basically, the kind of technical word. Yeah. How do you define the commit in normal English?
Commitment. What? You asking me that?
Like simply the commit. Yeah. Commit word.
Yeah. It means you're gonna stick to something.
But the commit word is normally, also used in, to seize the operations as well. Like, in the databases, yeah, you executed a query and the last commit, commit would be the, confirmation of the command.
Yeah. Okay.
Okay. So just wanted to give you an idea, that this word is mostly used in the programming as well as a key.
Okay.
Yeah.
Yeah.
So new requirements emerge. Communication with users is slow. Users often do not participate in reviews or are incapable of doing so. Users are technically unsophisticated. Users do not understand the development process. That is a main problem. Yeah. Like, it's not their headache that how, what should I say, the developers will maintain or create the requirements, yeah, because they don't understand that how a software developer needs to write it.
Yeah, okay.
Like a communication problem, like the first you know gave an idea, that's basically the communication problem. Because,
Yeah.
for example, if I'm a new, if I have given the requirements to some developers for 2 3 times, then I will be communicating the requirement very well by looking at the nature of the developers. Because
Okay.
some of the softwares would have been uh, uh, used by me, and I would know better that how I can explain and uh, tell the requirements to the development team. Yeah, but unfortunately, users, even they don't understand that in the process, that how they would be interpreting.
Yeah, okay.
These are very interesting bullet points, isn't it?
Yeah, it's interesting to take a different sort of view on things, isn't it? I wouldn't think of all these things. So
Yeah,
I just wouldn't think of this stuff. I would just assume that a developer would just get on with it, and that they would, they would be able to do it all without the help from users or anything like that.
yeah. Users do not know about the present technology.
Yeah.
So, like, software engineering subject, yeah, it's not, teaching you the programming at all,
No.
yeah, but it's teaching you a lot.
Yeah.
When we used to study the software engineering unit in our uni, there used
Yeah.
to be like a software engineering 1 and 2 in the first, phase. It used to be basic definitions, and then the further detailed, software. Yeah, I remember, the name of the software by Pressman. Yeah,
Yeah.
software engineering by
Yeah.
Pressman. That's another book, a kind of textbook on the software engineering. Yeah, that I studied, about 18 years ago, maybe. Yeah. So that's also, I would recommend you the software engineering by Pressman, and like this one, and software engineering by
Yeah.
Ian Sommerville. This is a kind of textbook. Do you have this one? Did I send you?
I'll just have a look a minute. Yeah, I think so. Let me have a look.
Otherwise, I would send you. So if we have a look, that there is introduction, software processes, agile software development, system modeling, architectural design, and they have classified into kind of advanced software engineering. Yeah, some of
Yes,
the
I've got that one.
yeah.
Yeah.
So some of the issues are being taught at the higher level. So what I was trying to say, that software engineering, doesn't teach you how to code, but it teaches you how to, supervise the software development, so that
Yeah.
you should produce a successful software.
Yeah. Okay.
So like requirement analysis, the issues with the stakeholders, they are, key tasks. Yeah.
Yeah.
So you need to take care of these, points. So like, these issues may lead to a situation where user requirements keep changing even when system or product development has been started. Yeah.
Yeah.
So requirement analysis issue, more important, what I would say, that if the requirements are good, like provided very well, then you are going very well, otherwise not. Next is engineer or developer issues. Possible problems caused by engineers and developer during requirement analysis are technical personnel and end user may have a different vocabularies. Very, yeah, very, good point. Because those who are only doing the software things, they would only be using the computing language. Other personnel would be using their own business language. Consequently, they may wrongly believe that they are in a perfect agreement until the finished product is supplied.
Yeah.
Engineers and developers may try to make requirements fit an existing system or model rather than develop a system specific to the needs of a client. Very important point. So engineers and developers may try to make the requirements fit an existing system or model rather than develop a system specific to the needs of the client. Like that even the engineers, they are good, but they would try to adapt their own development techniques. And sometimes even whatever the client is saying, but they would use their own. That's also a problem. Like it would be difficult for them to listen to the client because of the technological issues. Analysis may often be carried out by engineers or programmers rather than personnel with the people skill and domain knowledge to understand the client's needs. The engineer and developer issue, analysis may often be carried out by the engineers or programmers rather than the personnel with the people skill and the domain knowledge to understand client needs. So basically, it is saying, you understand what does this mean?
Kind of.
Yeah, can you explain?
So it's basically the problems that could be caused between the engineers and the developers. So that there might be like a misunderstanding somewhere between the engineers and the developers.
No. This says that the analysis of the requirement, whatever the requirements, needs to be provided by the domain knowledge or expert. But unfortunately, they are analyzed by the programmers or the engineers. That's a problem basically. Like I met with a kind of expert, an expert in the field. They should have analyzed and provide the full requirements, but normally that's done by the engineers and the programmers. And that's an issue. So because they should have give that kind of information fully, but it is not normally doesn't happen that they give a kind of piece of cake to the programmer.
Why do you think that happens? Why don't they do that?
Because the normal users, they have different vocabularies, and their beliefs are different, and the engineers and developers may try to make the requirement, they like developers have their own trend of creating softwares, like and the way they deal in their domain is slightly different. Obviously, if we want to create a medical expert system, then the doctor would be thinking in a different way, and we as a programmer would be thinking in a different way. Like the doctor would be thinking the other parameters, and we would be running the loops and the if statements in our mind. Like,
Yeah.
there is a saying like a cat may have always, the flesh in the mind.
Yeah.
So the engineers and developers issue exist. The next is, the design task. Yeah. So the system design task is the process of defining the architecture, modules, interfaces, and data for a system to satisfy a specified requirement. System design could be seen as the application of the system theory to product development. There is some overlap with the discipline of the system analysis, system architecture, and system engineering. So the design, yeah, is basically, gives a theory to the development.
Okay.
Like, you whatever you develop something based on a kind of theory.
Okay.
Yeah.
Yeah.
So, but like there is an overlap of understanding between the analysis, architecture, and system engineering. So some of them, they have their own places. Like, in design, the analysis is included already. Yeah.
Okay. Yeah.
But the design itself is a refined version of the analysis.
Yeah. Okay.
Yeah. So there is an overlap, and maybe this point may not be understandable by you at the moment. The only meaning is that different disciplines, they talk in differently.
Yeah. Okay.
Now, the architectural design emphasizes the design of the system architecture that describes the structure, behavior, and more views of that system and analysis. So architectural view, yeah, like we have an architecture of a kind of house.
Yeah. Okay. Yeah.
Logical design of a system pertains to an abstract representation of the data flow, inputs and outputs. Yeah, this is often done in the modeling, like an
Yeah.
abstract, modeling using, let's say, ER diagrams.
Yeah.
Okay, so architectural is, let's say, more, practical and concrete one.
Yeah.
Okay, physical design tasks relate to actual input and process of the system is explained in terms of how data is input to system, how it is verified, authenticated, how it is processed, how it is displayed. In physical design, the following requirements about the system are decided: input requirements, output requirements, storage requirements, process requirements, system control, and backup and recovery. Like a physical design task is, related with the physical, items used.
Okay. Yeah.
Yeah, you got it. Yeah.
Yeah. Yeah.
So further continued, implementation tasks. Implementation is the process that actually yield the lowest level system element in the system hierarchy, system breakdown structure. So the lowest, the system level, or the lowest system level in a sense that you start from the, uh, you know, you start from the top level, like requirements, and then the design and these things, and the lowest level, the bottom level is the implementation. Yeah.
Yeah. Okay.
Then system elements are made, bought, reused. Yeah. Production involves the hardware fabrication process of forming, removing, joining, finishing, and the software realization process of coding, testing. So that's basically the implementation tasks. Yeah.
Yeah,
The
okay.
purpose of implementation process is to design and create or fabricate a system element conforming to the element's design, properties and requirements. The element is constructed employing appropriate technologies and industry. Yeah. So that's too much, theoretical, unfortunately. Yeah.
Yeah.
But overall, yeah, the talks we have been, talking, they are a kind of, uh, a little more detail into the phases of the software development, isn't it?
Yeah.
Okay, fine. So, hi Tariq, can you hear me? Another, learner has joined. I have allowed to join, but I can't listen. Maybe he might be listening, but I'm going to continue this, you know, uh, session, and once the recording would be finished, then he may be able to listen it. Yeah.
Okay, yeah.
So let me, give a look, give it a, review again. So requirement analysis, you look at the problems in getting the requirements. Design task, you look at the problems at, problems are the critical things into the design, that whether you are considering the architectural design, whether you are, looking at the kind of abstraction level. Yeah. Then implementation related with the tools and techniques, whatever you would be using. Yeah.
Yeah.
So implementation task would be, task would be based on coding and these things. Yeah.
Okay, yeah.
Now, methods, techniques, and tools used. There are many software tools available in the implementation and integration phase. Obviously, the most basic method would be the use of n-square diagrams as discussed in this book. So one of the, these are the software engineering methods, and checking and correctness of the implementation. Proper implementation checking and correctness should include the testing to determine if the implemented element works in its intended use. Now, basically, the implementation is, tested against, the requirement. If you recall that evaluation, yeah,
Yeah.
evaluation is basically, do you want to define in your own words again?
I can't remember now.
Yeah.
Yeah, I can't remember what it is now.
So, I repeat it again. I would repeat, many times. Yeah. And believe me, these, definitions to, remember is worth to remember, for always, and they would give you, life in the knowledge. Yeah.
Yeah.
So, evaluation is that how the how it is meeting the requirements as expected. Like what you expected and what you got the results, that's basically the evaluation. Is it
How?
clear now?
Yeah. How it is expected? Yeah.
Yeah. How it was expected and how you got the results. We are going to evaluate. Another word is assessed. Yeah. When you
Asset.
say,
Ah, right. Okay. Yeah.
yeah,
Yeah.
assess, evaluate,
That's fine. Okay.
yeah, or assess. Yeah. So what happens, when we say the assignments, the assessment. Yeah.
Yeah. Yeah. Okay.
Assessment is basically like, what we expect. Yeah. We expect the answer in that particular order. Yeah. And we know that how well you have done.
Yeah.
Okay. So the implementation, whatever you have done, yeah. So you would have used the tools, and you are required to check the correctness of the implementation. It means your assessment should give an evaluation after testing to determine if the implementation element works in its intended use.
Okay.
Yeah. So what was the intended use? The expected, behavior of the system. Then the testing could include the mock-ups and the breadboards, as well as the modeling and simulation of a prototype or completed piece of a system. Now, so now there is, it's not only the one option of, checking the implementation, but there are a lot. Have you heard about the simulation?
No, I haven't.
Simulation is a general word. Normally, a kind of a dummy user.
Okay.
Yeah, it's a kind of dummy user. What happens, you try to simulate it. You might have heard about the, Android simulator.
Yeah,
Have you heard about it? Yeah.
Yeah.
So the implementation and is in front of you, and no matter, for example, you as a user could give the data to the system and you could check the results. However, a simulator, could check the system as well, that how the implementation is done, whether it is correct or not.
I see.
Yeah.
Yeah, understand.
So
Yeah.
once this is completed successfully, the next process would be the system integration. Yeah.
Okay. Yeah.
Now, software development and the business information. Basically we are, the topics, they are, not connected with, each other, but unfortunately we are following these keywords given to us, like analysis task, design task, implementation task, software development, business information, organizational aspects, and these things. You can realize that there is too much, uh, disconnectivity, isn't it? Yeah.
Yeah. So it's all a bit
Yeah.
all over the place, isn't it?
Yeah. But again, a recommendation to you and Tariq as well. This is the LO2. Yeah. You are always recommended a kind of textbook, which is the Software Engineering by Ian Sommerville, and another book is the Software Engineering by Pressman, and also the lecture slides, the chapter slides of this book are available. I will be able to provide you. Probably I would add into the Moodle, or I would be able to send via email. Yeah. So that you should focus on this software engineering book, and by reading this software engineering book, you will be, it would be helpful for you in software engineering, in information systems, and management information systems overall. And the lowest level would be the computer programming. So if you would be programming, you would be learning the computer programming, and your program would be made, coded against certain, requirement. Then the best way to get the requirement would be, followed by the techniques given in the software engineering, unit. Makes sense?
Yeah. Okay. Yeah.
Okay. So
yeah. That second book, the one by Pearson, could you send that to me? Because I don't think I've got that.
Yeah, definitely. I just recall, from my memory, that was the second book, and I haven't, tried, recently, but I would definitely find you the book.
Yeah, thanks.
Yeah, sure. So now the business development and business information. Software development is the process of computer programming. Documenting, testing, and bug fixing involved in creating and maintaining applications and framework resulting in a software product. That is the one point. Software development is the process of writing and maintaining the source code, but in a broader sense. Yeah, it includes all the all that is involved between the conception of the desired software through the final manifestation of the software, sometimes in a planned and structured process. Therefore, software development may include research, new development, prototyping, modification, reuse, re-engineering, maintenance, or any other activities that result in a software product. So, software development is a complete discipline, basically. The emphasis of this slide is that consider the software as a product. Yeah, it has to go through all of the concerns. It needs to be researched, and the next slide gives the business aspect. How a business model illustrates the functions associated with the business process being modeled and organizations that perform these functions. By depicting the activities and information flows, a foundation is created to visualize, define, understand, and validate the nature of the process. So, the business model needs to be presented into a kind of visual form. Yeah. And
Okay.
the visual form would be the analysis and design of the software development.
Okay.
Yeah. And that design needs to be followed for the implementation purpose. Make sense?
Okay.
Yeah. So, what is the relationship between the system development and the business information? The business information has, their business information is full of associated functions and business processes that needs to be modeled. Yeah, to give it a visualization. Yeah, and then that visualization, visualization that needs to be represented using the design. Yeah, the system design in terms of the software development, and then you should be able to implement it. Make sense?
Okay. Yeah.
And the data model provides the details of the information to be stored and is of primary use when the final product is in the generation of the computer software code for an application or preparation of a functional specification to aid the computer software. So, data model is basically the details of the information. The data model, for example, in the business terminology. Yeah.
Okay.
And the software terminology would be the software requirements. Yeah.
Okay. Yeah.
Now, the organizational aspects of the system development. Yeah. So, 1 second, let me. Okay. Let me try to complete these slides overall. So, multidisciplinary nature of the software development. In the nature of software development, here are 7 core ideas for the effective software development. Now, begin and end with a focus on a value. Give the product in terms of a small slice of working software. Organize around the work to be done with people who can do it. Plan in terms of features. Build in terms of features. Slice features thinly. Build quality in every day. Now, the software development should be done in this way. How? Let me, see 1, 2, 3, 4, 5, 6. Let me finish, the remaining these 3 slides today. Yeah. And I think we will discuss the these organizational aspects in the next lecture along with these LO3. Is it okay, Patrick?
Yeah, of course. Yeah.
Yeah. So, and obviously you are most welcome to go through these 7 aspects, yeah, in advance, and I hope that you can understand all of them, and we'll definitely discuss in the next lecture, and we'll go through one by one. Yeah.
Yeah. Okay.
I'm sorry, the units, they are like this specific unit is the theoretical one. I try my best to complete the LO in 60 minutes, but unfortunately because of the lots of things and lots of theory, I can't skip. Yeah. So
Yeah.
the programming team is very obvious that the team of people developing, maintaining computer software in numerous ways. Yeah, they should be egoless programmers team, chief programmer team are 2 common structures typically used. Yeah,
Yeah.
like overall team, egoless team and good software developers. Then the roles of the software engineers, the computer software engineers apply the principles and techniques of computer science, engineering, mathematical analysis to design, development, testing, and evaluation of the software and systems that enable computers to perform their many applications. They are involved in the design and development of many types of the software, including operating systems. So, what are their roles? Their roles are to incorporate the principle and techniques of software development.
Okay.
Yeah, if
Yeah.
they are following the principles, then they are doing their role. If they are not following the principle, it means they are not good software engineers. Simple.
Okay. Yeah.
Yeah. So if you are supervising the software engineering team, yeah, then you need to look at them. Are they following the their principles of the software engineering? Yeah, then it would be fine. If not, then obviously they are not performing their roles. Yeah. So the task of the software engineering, obviously they would be design, development, modifying, testing, and communicating, documenting these things in simple words. Yeah, I have just read the first word of the each slide. Yeah,
Okay. Yeah.
directing software programming, developing, analyzing, consulting with the team, staff, modifying, designing. So software engineering tasks, their roles, yeah. And the only one topic is left, which is the organizational aspects that we will discuss in the detail, and you are most welcome to read in advance. However, we discussed the difference between the business nature of the information and how it needs to be converted into the software development information, and we discussed the implementation, which is coding. Basically, you should be aware of the architectural design, then requirements, what issues come in the requirements from the developers, from the users, the type of the requirements. That's it we discussed today. And I would advise you to go through the software engineering book and the slides. Yeah, and at any time if you need my help for the resources, you are most welcome to ask by email. Yeah.
Okay. Yeah. I'll.
So, okay, thanks for attending the class, and I would see you on Wednesday. Yeah.
Yep. See you Wednesday. Thanks.
Okay, that's fine. Thank you very much, and bye.
Cheers. Bye.